morning, everyone. Yeah. While waiting for the slides, I just want to say, later on I'll be, it's not this, I'll be sharing the slides. I made some changes to it. And later on, there's another session after lunch. It could be a bit lengthy. I'll try to go a bit faster, but I think that session will be something very interesting. It teach you how you could look at different wallets, how you create cryptocurrency wallets and so forth. This session is a bit more boring, but it is still useful. So I'll just start from here, all right? So I'm talking about smart contracts and DApps. Are these terms something that is foreign to anybody? Smart contracts, you know how it works? Yeah, okay. So I'll just go through. So how that works. So these are all decentralized applications, or DApps, or we call it DApps. They are like software that runs on a blockchain or P2P network. I have friends who came to me and say, so what's the difference between your apps and your DApps? To be very honest, if you look at it from user interface wise, how this thing is being structured is actually almost the same. The function is the same, the way you want to launch an application is the same. That's how it's supposed to be. Then some people say, then how do you know whether it's DApp or not DApp? Okay, you will not know, because these are things that are running at the back end, right? But for us as a user, it will be important to see and have a very nice user experience. So a lot of these DApps look exactly the same as what you have. So key features, is decentralized. It operates on a blockchain network, not controlled by a single entity. Immutable, so data and transactions are securely recorded, cannot be altered. Transparent, code and transactions are visible. There's also an incentive program, for participants to take part in it. I think the whole concept of how we tell people what blockchain is really all about revolves really around all these very key principles, And whenever you are back, in your home country, you will be asked, oh, so what have you learned? What can we implement? What can be done better? Yesterday, my key message to everyone is to keep things very simple and small. Today my key message to you is to try and look at it in a more sharper angle. Something, maybe you can look at something that is more automated. You could use the smart contracts to do some of the existing work that is being done by manual work. Use something like this so that your ministry understand how the whole so-called blockchain or DApps or whatever you call in your country, it could be like a decentralized digital system and so forth. Just tell them that, hey, we are trying to automate some of this process using smart contract, and that's how it is. So example of that, like PancakeSwap. PancakeSwap is part of the Binance family. Anyone know about PancakeSwap? Okay, many people are nodding ahead. It's part of the Binance family, and they function as a platform where they let you exchange BEP20 token. It is designed for smoother user experience minus the high transaction fees. So again, if you have time, if you want to explore how PancakeSwap works, I'll be very happy to show you as well. Basically, it transfers BEP20 token. This is like a token standard managed by this BNB chain, which is part of Binance. They have a maker fee of about 0.2%, and it's compatible with various crypto wallets and so forth. And all the governance are being done by their own native token, which is called Cake. I have a very quick video how creating a wallet, how to use PancakeSwap, because like I said, I'm not here to promote cryptocurrency, but I love to share the knowledge with everybody. So let's take a look at the video, how this is being done. Santi, thank you.
In this video,
It's a Trust Wallet. So Trust Wallet is also part of the Binance ecosystem.
If you're an Android user, head to the DApp browser and type in PancakeSwap.finance in the search bar, or head down to the DeFi section and tap on the PancakeSwap DApp. If you're using an iOS device, simply head to your preferred web browser and type in PancakeSwap.finance, then Connect Wallet. Select Trust Wallet and accept the connection to PancakeSwap. Once you're connected, you can check your wallet out. There are a number of features in the package.
Through farming and pools, competitions and lotteries to their very own NFT collections and marketplace. But that's for another time. We can tap on the swap option here to see the initial swap list, or we can add a custom token address here in the search bar. Please note, if you're adding a custom token, be sure to research the token you are aiming to swap first, as some tokens could be scams and may result in a loss of your funds, and you may not be able to trade them back. If we tap on the Manage Tokens, we can turn on the top 100 tokens, or we can also toggle PancakeSwap's extended list to see the full listed range available. You can fine-tune your swap preferences by heading to Settings. Here, you can set the transaction speed, slippage tolerances, and deadline. It's fine to leave these on the default settings, but just in case a token has lower liquidity, you may want to try and increase the slippage to 1 or 2% if the transaction doesn't go through the first time. Slippage is the difference between the expected trade price and the executed trade price. I'm going to swap my Smart Chain BNB for PancakeSwap's native token, Cake. But once you've found the swap you'd like to do, just enter the amount you'd like to swap and select the swap button. A smart contract call will appear in your wallet. Just tap confirm if everything looks okay. If you don't see the token appear in your wallet automatically, you may need to add the token as a viewable asset. Just tap on the icon at the top right, search for your token and toggle on. Now your asset should be visible. You may want to swap Ethereum. Well, as PancakeSwap is built on Binance Smart Chain, you'll need BSC or Smart Chain BNB. If you only have Ethereum tokens, you could swap or wrap them for the Smart Chain BEP20 equivalent on Binance Bridge. Just head to Binance Bridge, connect your Trust Wallet, and swap or wrap your Ethereum-based tokens to BEP20 token standards.
You know, there are a lot of different
Trust
token
Wallet is the
standards.
perfect
I'll
place to
explain
store
later
all of your
a
crypto.
bit more. Yeah. So this whole process looks very foreign to many people, to be very honest. You know, why would we be talking about cryptocurrency? How are we going to do the swaps and so forth? You know, in one of these research that I was doing with a European ministry, you know, they were even thinking about, you know, creating their own fiat currency into crypto-like currency. So some of them, they will call it CBDC, central bank digital currency, you know, but another step further to that is they might, or some government might even really look at this from a very much crypto standard instead of looking at this from just Ethereum, BNB. You know, a lot of these things are very foreign, or Arbitron. Maybe yesterday a lovely lady was telling me about that. You know, they are actually looking at using this as a form of FX as well. You know, so this interface might seem to be really complicated, but if you stick with a certain standard, for example, I'm actually talking about BEP20 standard, you know, or Ethereum standard, is very straightforward. You know, the kind of address that you put in, the kind of money or token that you want to swap. After a while, you get used to it. You know, we could get into an exercise to do the wallets and so forth. But like I mentioned, you know, I'm not here to promote cryptocurrency, but I'm here to make you understand that such thing exists, and this is a DApp that is very widely used in the crypto space, and it also a very good standard, for other people to look at it, how it works. If your government is going to implement something that has to do with incentivization, you just think about it this way. Maybe you have a lot of different chain, right? So instead of clicking on Ethereum, you may be clicking on the Ministry of Finance, and then you have your own incentive program, right? And then if you are talking about maybe manpower ministry, you have your own incentive program. So there's a lot of ways to do it. Of course, the easiest way is the best, but these are some of the ways that we see in the market, right? So example of that, like Ava is a poster child of this DeFi. Talk about different liquidity, how they borrow, how they earn interest. The cool part about this is that the transaction fee is low, the interest going back to the users are high. So this protocol itself is open liquidity. Whatever lending you want to do on chain, you'll not know who is the other party, right? And it's all very smooth. Whatever you want to loan, you have enough collateral, you just do it. Introduction to smart contract, right? So smart contracts are self-executing contracts is the term of the agreement written into code. Smart contracts are stored and replicated on the blockchain, ensuring security and immunity. So how this works, you connect to your chosen blockchain network, create a front-end application, and then fund your collateral account to transact with cryptocurrency. So again, the front end is very similar to what you see. API is the same as what you are doing. So what will happen is that there's a write process. You initialize the smart contract on the blockchain, then you perform the necessary technical integration. Then all you need to do is to deploy the smart contract. So this is how it works. So matchmaking of a seller and a buyer, then there's a transaction, and then you receive the asset. Everything will be registered, settlement automated, and there's no real need of third party. So these are more widely used in the finance sector. For myself, we use it more with the contracts. We use this to correspond with some of the lawyer, because some of these contracts are, to be very honest, very, very easily. It's very easily vetted. Just a few different columns that are different. So we use a smart contract to interact. So how dApps use a smart contract? So dApps rely on smart contracts, but smart contracts don't really rely on dApps. DApp use a smart contract to automate many processes ranging from core services of the application to general governance functions. So one good example, going back to the previous example, they are a peer-to-peer lending and borrowing staking platform. dApps and platform like Uniswap, for example, there's also another decentralized app which is very similar to PancakeSwap, but they are only using the ERC20 Ethereum standard. They use that to enforce election processes. They use that to also build on a lot of different administrative functions. Again, some of these things are going to be really foreign, but just look at it. There's a different swaps, different kind of standards. So smart contract based on application. So I mentioned before, there are the legal contracts. Smart contracts combined with legal contract template. These are very, very widely used, at least in my circle. DAO, this is a decentralized autonomous organization. Is how should I say this? Some to be very honest, right in the very beginning, these DAOs are actually groups that gather together in a more free manner, to make some decision together, right? Everybody will not know each other and so forth, but because as DAO evolved, our friend there from Pakistan, he knows about NFTs and so forth. He must have joined a lot of different DAOs. Eventually, right now, things has evolved, right? The function is the same, they will be there to kind of govern, protect the project, make collective decisions together. In the past, nobody really know each other. But right now, because how DAO evolves and how people want to be the face of a certain project, now in DAOs you can actually know who they are. Maybe not everybody, but at least 70 to 80% of them, exactly who they are. So they make collective decisions together. And then that's, is a combination of smart contract codes and then smart contracting device, combined with IoT devices and so forth. So this is a programming language, used for writing Ethereum smart contracts. I'm not a programmer. I don't do codes. I look at different policies. I look at different commercial aspects of things. I dare say that a lot of these Ethereum contracts are using this language. All you need to do, developers, what you can do is to define the variables, the functions, the different events. Set the conditions for the contract action, enable the automated action. Leverage on the object-oriented concepts and reusability and design. Again, I'm not here to teach you how to code, or where you tag, how you tag things and so forth. I think the session is mainly to allow you, when you go back, you really want to implement, you'll be talking to many different kind of programmer, developer, consultants and so forth. At least you know the language. When you go back, do a bit more research on your own. From there, you could interact with them a lot better. If not, it seems like they are like trying to force you to go a certain way, right? So once the code is written, it is compiled by bytecode, which is the EVM, as we all understand. So EVM is where the magic happens, where the smart contract comes. So how to write the smart contract, yeah? Again, I want to emphasize I'm not here to teach you how to do coding, right? But a lot of these things I will explain to you at the end. Actually, most of these things are all widely available, all right? So you open the storage, and then input the following codes. On the initial line, we specify the SPDX license type. Whenever the source code of a contract is made publicly available, this license can help to avoid and also resolve some copyright issues. Well, then the third line of code, it declares which solidity this compiler that you use. In this case, we are using any version equals or between 0.82 and 0.90. On the fifth line, then we declare the contract, and in case we just name it as storage. It's a common practice to use the same name for the file and contract. Sixth line, this is what you see, executing the different functions. Just a few lines of code here. 7 to 9, we declare the set function. This will take a certain parameter assigned to the certain data. So you can see here, this is the data, and data equal to X. In the last couple of lines, you add the get function where it returns a value of the data. So this is what you see. Again, is nothing that is too lengthy or too many lines and so forth. So if you want to really look and explore further on how to do a smart contract, you can always go to GitHub. There are many different kind of repository for you to look at and see how you want to use them and how you want to modify them. Like I say, a lot of this blockchain programming for smart contract wise is just a very short code. It's sometimes very easy, and sometimes I make it look too easy, but but also at the same time, sometimes when you are being approached by some developers, they will charge you an arm and a leg. But if you really do your work properly, you can actually save a lot of time and so forth. But at the end, I'll share another video, and I think that video is is a bit lengthy, but it is something that is very useful. Yeah. So why create a DApp? I mentioned, these are all the different pros that we see, because you have excellent uptime, how the blockchain functions and so forth. Again, the 7 different steps that I iterated here. Step 1, define your DApp concept. This is very similar as how you do your applications anyway. Design your DApp architecture, develop the smart contract, integrate with the blockchain, whichever that we want. We need to look at the decentralized storage, test, deploy your DApp, and maintain your DApp. Again, this whole process is not something that is foolproof, but in general, these are good practices. Sometimes if you again talk to different people and so forth, they say, oh, blockchain projects, there's no need to have any storage, because it's peer-to-peer. That's not true. We really need to have our own storage. Yeah. If not, you'll turn out to be the NFT example that I have yesterday. 2021, you bought NFT because you have no storage right now. You click, you see nothing. Maybe just a few lines of code. Okay, like I mentioned, define your concept. Identify the use case. And then you research on the different blockchain platforms. And the concept should always be something, again, straightforward, easy to find out what is the gap that you're trying to solve. Then you design your front end, your back end architecture. Develop the smart contracts, choose the language. There's a lot for you to choose. Some can even be more automated, some needs a little bit more work. But don't worry, in general, it's simple. Integrate with the different blockchain, compile and deploy the smart contract, get the interaction with the smart contract, do the testing. Like Dr. Ram mentioned, they do a lot of different testing, test from the server, test from the user perspective, you all have to do that. Storage, IPFS storage, or right now, if you really are into this, this Telegram and the Torn blockchain, they are also doing a lot of different storage solutions using this mini program or micro programs. Test and deploy them, straightforward. This is exactly the same as what you experience in your own app, 100% the same. Maintain them. This video is a bit lengthy, but the thing why I want to share this video is I think right now at this current moment, we used to employ a lot of different developers. I'm not a developer myself, but we used to run different projects, and also from an investment company, we incubate different projects, So we used to have probably about 100 developers, but because right now, thanks to the ChatGPT and all the rest of the AI function, the number of developers has significantly dropped. I had a very small conversation with Ram yesterday about how I used to get more developers from India, and now we have dropped a lot. It's also mainly because of AI, So this video itself is going to take a while. Take a read, This friend of mine, he's always very, I say, maybe more direct, in terms of how he wants to teach you, And to be very honest, using the ChatGPT or any other AI language, you could always use that to check your smart contract. That it is actually a lot better than using human because they don't have any emotions. You just run it, test it, run it again. So let's get into the video. This is my moonbeam.
Hello everyone, it's Kevin, and welcome back to another tutorial. In this video, we'll be taking a look at how ChatGPT can help you with your smart contract development. GPT-4 is the latest version of OpenAI's AI language model, and that's the version that we'll be looking at today. Essentially, it's a super advanced chatbot that is way smarter than any chatbot you've ever interacted with in the past. In fact, I hesitate to call it a chatbot because it's kind of insulting to GPT-4. The official name of it is a language model, but you can also call it a text-based artificial intelligence. It's been trained on an enormous amount of data across the internet, so it's familiar with just about anything you can think of, including Solidity smart contracts. It's so capable that it can not only teach you how to write Solidity smart contracts, but it can also help you debug them. You can copy and paste your code into GPT-4's interface, and it can help you find errors in your code. GPT-4 is context aware, so even if it doesn't produce the right answer that you're looking for right away, you can ask it to revise its answer, and you can sort of steer it or guide it towards the best solution that suits your needs. If you've never interacted with GPT-4 before, it is nothing short of a breathtaking experience. The knowledge, the reasoning, the capability, its level of understanding is unbelievably good, and truly it's nothing short of inspirational. And no, this introduction was not written by GPT-4, although that's certainly something that it is capable of. Now, a couple of disclaimers before we get started. GPT-4 is not infallible. It does make mistakes. Sometimes it can seemingly invent or hallucinate answers that sound reasonable, but may not be factually correct. The code that we'll be producing today, with the help of GPT-4, is for demonstration purposes only and should not be used in production. Lastly, GPT-4's training data includes content up to about September 2021, so generally speaking, it cannot answer questions about things that occurred after that date. And I want to give a quick table of contents as to what we'll be looking at today. First, we'll ask ChatGPT to create an ERC20 token for us. Then we'll ask it for hard hat deployment instructions, and we'll ask it to create some test scenarios for us. And lastly, we will give ChatGPT a known buggy contract, and we'll ask it to tell us what's wrong, and it will explain to us what's wrong and how to fix it. So let's go ahead and get started. First thing you want to do is head to chat.openai.com, and if you don't have an account, you can easily sign up for one. Otherwise, you can log in. I already have an account, so I'll go ahead and log back in. And if this is your first visit, you'll be greeted with a couple of warning messages and reminders here from OpenAI. So we'll go ahead and continue. And the first thing to point out here is, in this video, we'll be working with GPT-4, which is the latest model, and that is part of a subscription service called ChatGPT Plus. I believe it's $20 USD per month, but the concepts pointed out in this video, they apply to all of the models. So you can use it in GPT 3.5, which is free. That's perfectly fine. However, if you have access to GPT-4, I would highly encourage that you do use it because it is quite a bit more advanced of a model.
Just to let everybody know, we are still using 3.5.
And its level of reasoning
is as good as for when we talk about
but it applies for both, so you're welcome to give either a go. So first thing I'm going to do, actually, I want to turn on dark mode. I just think it looks a little bit nicer. And what I'd like to start off with is I'd like to ask GPT-4 to create an ERC20 token for us. I'd like it to be called Kev token. I'd like the symbol to be called Kev. I'm going to specify an initial supply, and I would like to specify a specific account that the initial supply will be sent to. So, fairly simple prompt. Let's go ahead and put this into ChatGPT, and let's go ahead and give it a whirl. So GPT-4 is producing for us a simple ERC20 contract using OpenZeppelin. It's naming the token Kevin with the symbol KEV, just as we asked, and it's specifying the initial supply as we asked as well. Finally, it's minting the initial supply, and it also has some unprompted error checking to ensure that the initial supply is not accidentally sent to the burn address. Additionally, GPT-4 reminds us that this is a simple contract, and you may wish to extend it with additional features like burning or other contract logic. Let's go ahead and kind of guide it along. We'll maybe ask some follow-up questions about deployment and things of that nature. One change that I'd like to make here is that it hard-coded this address here, and I think there's a nicer way to do that. So let's ask it to revise this to take the initial account here as a parameter in the constructor instead. And GPT-4 is happy to make that change for us. And it doesn't just spit out the one line, but instead it gives us the entire contract again with the changes that we requested. And it's also building in a little bit of logic here. It's making sure that the initial supply recipient is not the 0 address. And that's quite beneficial. It even includes a warning message in the event that it is. And so we're quite happy with this. This is just the Solidity smart contract code, but ChatGPT can do much more than that. It can give us compilation instructions, deployment instructions, and much more. So let's say that we'd like to use hard hat, and let's ask for the steps kind of from beginning to end.
So if you look at this, it's very similar to what I mentioned. The number of codes, lines of codes, they're all very straightforward.
Very detailed instructions. And we're not just going to take GPT-4's word for it. Instead, we're going to go through and actually take these steps ourselves to kind of follow the mantra of don't trust, verify. But this is looking very promising. And it's even advising us that we shouldn't hard code our private key. Instead, we should use something like a secrets.json file, and it's giving us the exact structure of what that would look like. If you're new to smart contract development, and maybe you were unsure of the formatting of the secrets.json file, maybe you didn't have an example in front of you, this is really wonderful that it gives you that. It's also giving us a deployment script written in JavaScript, which we can use to deploy our smart contract to Moonbase Alpha. Really very, very exciting. And again, we're going to take all these steps once it's done generating. One thing that I will point out, GPT-4 has a limit of 500 words, essentially. I think they call them tokens, but it has a hard limit, but its train of thought actually continues. So if it abruptly shuts off, kind of in the middle of a sentence or in the middle of a word, you can just ask it to continue, and it will happily continue the prior train of thought that it was working on, and this will just count as another message against your limit. So all of this is looking excellent. Again, let's go through and follow the exact steps that it has outlined for us. So I'm just going to adjust the windows a little bit here. Let's go ahead and follow the setup instructions. So it's asking us to install hardhat, and it's giving us instructions for where to store KevinToken.sol. So I'm going to start here, and we'll go ahead and install hardhat. Cool. I already have a directory here, so but I guess we'll follow the instructions verbatim to follow the spirit of GPT-4's instructions here. And then it says go ahead and create an empty hardhat config when prompted. Cool. Then we're going to install the required dependencies here. And we're going to create a new file, and it's even specifying that we should do this inside of a folder named contracts. So that is very wise to give us those instructions. So you can do that in the UI, or you can also just run this command to create a contracts folder. So let's go to our contracts folder, and let's go ahead and create KevinToken.sol, and we're going to copy and paste the contents of it verbatim. It even has the practice statement, and it correctly imports the OpenZeppelin library that we'll be using, the ERC20.sol contract. So let's save that, and it has the correct way that we wanted, which is the address specified in the constructor. Cool. It's even telling us that we should create a secrets.json. So let's do that, and we're going to do this in the root directory. So I'm going to create a quick new Ethereum address. The private key is going to be exposed, so this is only for test purposes. And let's actually copy the exact formatting here that GPT-4 recommended. Okay, let's save this. Let's save this. And because this is Moonbase Alpha, we're going to have to get some faucet funds. So let's head to the Moonbase Alpha faucet, and let's go ahead and fund this account. Cool, and we're all set there. And let's go ahead and work on the deploy script. To give a quick rundown of our deployment script, we use ethers, and because we're deploying a contract, we need a signer. Whenever we make a state change to the blockchain when using ethers, we always need a signer. Whereas if we're just reading from the chain, we can use a provider. And a provider doesn't require a seed or private keys, so it's a bit easier to get set up. The get contract factory method indicates that we want to deploy a new smart contract, the Kevin token to be specific, and we're going to define our initial supply recipient and call our constructor. Lastly, all of this is wrapped up in a main function, and that main function is then called at the bottom of the script, and if any errors result, they will be caught and the script will stop running. So it's advising us to create a folder named scripts. So let's head in there. And let's create the deploy.js script. And we can just take a minute and appreciate how convenient this is. I mean, it has all the names here, the names that we specified. It has the address that we specified, that it's using as a parameter here in the deployment script. It has some logging. It's really, really excellent. So we're copying that verbatim. And to this point, we've done everything that ChatGPT has advised us to do. Let's go ahead and give it a whirl and see if we can get this deployed. Cool. So there, we seemed to have missed one step. Did I? Yes, I forgot to copy the hard hat config.js. So let's take care of that now. Yeah, I forgot to copy the changes here. So what I'm going to do is I'm going to actually delete the file, and I'm going to copy and paste the exact contents as GPT-4 has specified. And we mentioned that we wanted to deploy to Moonbase Alpha, and GPT-4 is knowledgeable enough to have one of the public RPC URLs for Moonbase Alpha correctly listed here. So really fantastic to see. And it's also requiring that we have our secrets.json and our private key. It's importing. It's got the correct chain ID. Everything's correct. Everything looks correct here. So very pleased to see that. Let's copy and paste the contents here. Save it. And let's try the same command here. It even advises us how to get dev tokens for Moonbase Alpha. Unbelievable. Very, very exciting to see. I see. So rather than, we can fix this ourselves. And all we need to do is install the OpenZeppelin library locally, and then hard hat will be able to work with it that way. But something that shows you the power of GPT-4, again, it's context aware, so it can remember your conversation, and we can actually copy and paste this error into GPT-4, and it'll give us some troubleshooting steps, and most likely the correct answer will be in there. So let's go ahead and give it a shot. Wonderful. Let's go ahead and give it a shot. Let's make this change. save it. And let's go ahead and run the same command again. Oh, we're in the contracts folder, so let's head back here. Missing a license file, not a big deal. I've seen plenty of runs where GPT-4 does include a license identifier. In this case, it chose not to. It is a language model. It's not going to produce the same answer every time. And so that's something to definitely think about. And it looks like everything was deployed successfully. We can take a quick look here with the address of Kevin token. So we can head to moonbase.moonscan, and let's go ahead and take a quick look. And everything's deployed here, looking great. So just a couple of things to point out. GPT-4 does make mistakes sometimes. You saw it with this import statement. It's not going to be the same error every time. You might try the exact same inputs and it might produce a different result, right? But if you get an error, you can put that into GPT-4 and it can help you fix it. Now, in this case, the answer was pretty straightforward, right? Here's what you need to do to fix it. Here's the exact fix. Occasionally, you might have something where it's less clear what the mistake is and less clear exactly what the answer is to fix it. And in that case, GPT-4 is amazing at giving you a whole list of troubleshooting steps. It might put out 4 or 5 different things that it suggests, and if none of those work, you can follow up and say, hey, I tried all these things, it didn't work, what should I try next? And GPT-4 will give you more things to troubleshoot. It might say, could you copy and paste your code? It might say, what does your file structure look like? It might say, have you made sure that you've installed everything? It's really smart at detecting issues and helping you push through as a developer and sort out any issues that you have. It's really incredibly powerful in that sense. So we've learned that GPT-4 can write a Solidity smart contract for us. We've learned that it can write a deployment script. We've learned that it can fix errors and tell us how to solve them, and it can do more. So one thing that's very important, of course, is for any contract to have tests. And you can write them yourselves. You can also have GPT-4 help you with your tests. So we'll say, hey, so GPT-4 has given us a bunch of different tests to use for our Kevin token contract. It's described how it's structured the tests, and it's let us know how we can go ahead and run the test suite. It's given us a reminder that this is a basic test suite, and it may or may not match your needs. Again, all of this should be used just for testing purposes and not within production. But certainly this can be used as a really wonderful spring and launching point for expanding and writing your own tests. And even if you're not going to include tests that are exactly similar to these, it can certainly help you structure your tests, right, and give you a framework for what you might be looking to write on your own. For the sake of time, I won't be running these tests, but I wanted to show you that it was possible. All right, and lastly, before we wrap up, I mentioned that GPT-4 can help you spot bugs in your smart contract. So what happens if we paste in a smart contract which is known for having some particularly pesky bugs, and let's see if GPT-4 can recognize the issue. And the bug that we'll be asking GPT-4 to find today pertains to reentrancy. And reentrancy was actually the issue that brought down the DAO. The first DAO, or the first one to gain national prominence, was the original DAO in 2016 on Ethereum. And users could pledge or deposit their ETH tokens into the DAO, and they can vote on how they'd like to see it distributed to projects, with the hope that those projects, would succeed and would be a good use of funds. Now, there was a fatal flaw that was very critical, and you can see this exact flaw here. For a user to withdraw their balance using the withdraw balance method, it used this old insecure call, which is deprecated now. You should now use the transfer function. But in this case, the function here would allow the user to withdraw their funds, and it's at this point at which the value is transferred. And then the user's balance is zeroed out. Now, a user could call withdraw balance and then have essentially a recursive call to call withdraw balance before their original balance here was zeroed out. And this would allow them to take out more than what they had put in, essentially stealing funds from the DAO. And the fix to this is to zero out the user's balance before any funds are transferred. And this is how the reentrancy bug could be prevented. This is an important history lesson. Let's see if GPT-4 can recognize what's wrong. I'm going to copy and paste all of this minus the insecure comment at the top. GPT-4, of course, spots the issue right away. It gives you sample code here for how to fix the issue, and it rewrites the withdraw balance here, specifying that the user's balance is zeroed out before any funds are transferred. Of course, this is just for demonstration purposes and should not be used in production. And we specify here a very common error with reentrancy, but the point that I want to make here is that GPT-4 is extremely useful at recognizing not just straightforward errors, but ones where you're genuinely stumped. You could have searched Stack Overflow. You could have Google searched for your potential error messages, and maybe you even tried a couple different things. But GPT-4 can send you through an advanced troubleshooting loop, again, 5, 6, or more steps, and let you know exactly what you should take a look at. And not just for simple errors, but for potentially more complex ones, potential deployment issues, configuration issues, setup, and really GPT-4 can remove blockers and help you move on to what you want to do, which is to build and deploy your DApp. Remember?
All right. Again, I'm not here to sell ChatGPT 4 plus service, but what I'm trying to do is to make things a lot more practical. You know, many of us here are not programmer, you know, and again, like I mentioned, you know, the developers that we hire has dropped at least about 70%. You know, this is because of ChatGPT and how it spots different error. You know, it helps you to do a lot more things in a more automated manner than really developers. You know, sometimes you have to beg the developers to do this, do that faster, and so forth. You could always use a ChatGPT to run some of these functions, or even try to spot some of the error that you encounter, you know, before reaching out to your developer again. You know, so again, not selling ChatGPT function 100%, but it will be good if you want to try out how to create a smart contract. You know, instead of listening to me how to code, and then you will say, oh, Andy, that's just that few lines. You know, are you sure this is going to work? You know, if you are not a programmer, you just want to try it, just use the ChatGPT to run some of these smart contracts. You know, to be very honest, one of my lawyers who did the smart contracts for this legal contract, you know, is actually written by ChatGPT. Of course, he said to other people that, oh, I use a developer, this and that, you know, but it's not. It's run by the ChatGPT because I was actually with my lawyer, you know. So I'm not asking you to trust 100% what ChatGPT can do. You know, there are many different ways that you can debug. You know, instead of just using one AI model, you can use multiple AI model to do a bit of debug. To be very honest, I think it is, programming-wise, I think it is still considered highly trustworthy in my humble opinion. If you're using it for other productivity purposes like writing articles, so I write a lot of different articles, don't use that, man. Because after you use it for a while, you realize that, oh man, you know, people will know that you use the AI to generate out all your comments, you know, and that's not going to be too good. But programming-wise, at least from myself and some of my own developer, you know, they felt that it is actually a lot more convenient, you know. So these are some of my final words. You know, these smart contracts and dApps represent the future of decentralized technology, offering numerous advantages in terms of security, transparent, and efficiency. this is actually proven. Again, in my own opinion, it's proven. In fact, when we had this kind of hackathons, with different projects, with different blockchains and so forth, some of them really use AI to really code them, and some of them are also there because they want to build a more decentralized chain. Next, sorry. I like this. Whenever I see the emoticon, means it's gonna be done. So again, if you want to learn more about coding and how it's going to work, I can share with you some resources. I have my fellow colleagues that could also help you if you need anything. Or you can text me. I could always get them to run the different tests for you. Just as a second opinion. Don't worry, no fees at all. Text me because we run a lot of different projects, and we also have our own developer that could really help you. Sometimes how should I say it? Because we really deploy different projects on different companies, with different companies, different ministries and so forth. You realize that a lot of these vendor, they have their own way of selling you their platform and software, but if you want them to really do something new, that is very blockchain centric or very decentralized centric, sometimes the way they deploy it might not be perfect, because a lot of them they know the theory, but they have not actually deployed or do a lot of work within that circle. So again, if you need any of this help, you have my number, ping me. I would always set it up with one of our developer to help you to troubleshoot, or to just just clean up some of the codes on our end. So after lunch, you'll be a session about cryptocurrency. Well, I have about 70 slides. I'm not sure whether I can finish it, but I will try to zoom in fast and let everybody understand, the general concept of how cryptocurrency work. How you create your own digital asset. From mainly from an NFT angle. Because right now, actually, by using the smart contract that you see just now, he actually created also a digital asset, his own token. Maybe he is Kevin. I can create an Andy token. So that is also a way to create. But later on, I'll teach you other ways using other platforms such as OpenSea, Seed.photo if you are a photography enthusiast, you could use that. And also other community-driven kind of DApps where you can also take part and experience how the cryptocurrency communities are like and so forth. With that, I'm done. Can we lunch next? Sure. Since we lead coupon again, Q&A. Ask me anything. In the crypto community, there's a lot of different sessions where they call it AMA. Ask me anything. Well, trust me, man. If you are in a project or you invested in them, the kind of question that you receive is scary, because they ask very scary questions. Especially when yesterday, I think Bitcoin dropped to 49,000, 48,000. Everybody is so sad. Anybody is sad? Don't worry, it will drop more. No. I hope you will not be, okay? Any question really,
So in next session, we are learning something about cryptocurrency.
Learning about cryptocurrency, learning about how you create your own digital assets.
But how this cryptocurrency is related to our training session about e-governance? Because we are learning here about e-governance.
True.
I think the cryptocurrency is something different from e-governance.
To be very honest, when I first did this like 5 years ago, I'm also a very nice trainer. I tell you what kind of project is best to have blockchain. But after 5 years later, the methodology is very different. I just want people to deploy because deployment is very low. Your question about cryptocurrency is very sharp, and I like it because sooner or later, when governments start to look at central digital currency, central bank digital currency, or maybe they have other form of incentive program that the government wants to roll out. You know, it will and it can be very similar to cryptocurrency. You know, so don't see if you see e-government application of e-government as a form of, you know, back end trying to see how this coding is done, you know, then it's very similar to what you have already know. You know, it's the same as what the digital world is about. If you talk to your tech guys, they go back, they'll say, hey, this is the same as how I do my procurement right now. But actually, it's not the same. You know, if you look at it, slight differences. You know, it's not the same. Same for cryptocurrency as it evolves. Different ministry or different government will start to look at it in a different light. You know, some countries, I can't name who, they are doing their own stable coin. You know, is it an application within your own e-government? It is, because next time you will use their currency to pay. You know, instead of paying in cash. You know, right now, well, you know how the money supply and so forth. I don't want to explain, but you know, things will change. Really, things will change. Yeah.
Yeah.
I
have a question. Andy, thank you, Dr. Andy, thank you for sharing with us this tool, the GPT 4.0, and we can leverage LLMs for generating codes. It makes our lives easier. My question primarily is on how we will be able to scale up. Since you've mentioned that we can write our own smart contracts and we can deploy it, test it in an environment, like limited environment. You always mention that we can start small, we can start with practical applications. However, if you want to test this on a real environment, since smart contract, I think Ethereum, it has gas consumption, and we want to test also the performance in terms of like some bottlenecks potentially in the network and the computing resources that it will require. So definitely it will have an effect eventually in gas fees and gas consumption. So if we will be able to test it in a small, or would you recommend any approach on how we can test it and make it scalable somehow and check if there's performance concerns in terms of your network computing resources?
I think the first question is about transaction fees and so forth, right? So it really depends on how big of a data or how much data you're trying to transact. You know, some of my friends, if they are going to use things that are more EVM compatible, so they will just use the EVM compatible chain or the layer 2s, which are relatively cheaper to do all the different tests. You know, so that could be that will answer to your transaction cost thing. And to be very honest, if you build this on the EVM, you know, the scalability and so forth, you know, and the uptime of the server, you know, the latency of the server, all of this can be tracked in the public blockchain. So I don't see that as an issue. But for testing purposes, you know, you could even create your own private blockchain just to test it. You know, then you will not have all these problems. But of course, the private blockchain, eventually, if you are going to deploy this on a public blockchain, the kind of performance will be very different. You know, so if you want to do it in real, you know, like a test, I would rather you trying to use like EVMs to do it. You could use things like Polygon. You could use things like Manta. You know, all these blockchains are there. You could use that as a trial and error. You know, fees are relatively lower. Things are relatively the same. So time's up. Lunchtime. That's the best.
We continue our discussion. We can use the concept of this. You can go next.
This class